Okay, so graphing our curves. We're going to do type of curve, maximum R value, and symmetry. Again, you're not doing any of this from memory. You can always put it in your calculator. So that's how I'm going to start. 4 minus 3 cosine of theta. Now, my calculator is in polar mode, so I have R's and thetas. So if you need to get there in the TI-84, you go to polar. The other thing I've done is under format, polar coordinates instead of rectangular will give you R's and thetas when you trace, which is particularly nice. So again, 4 minus 3 cosine of theta is my polar curve. And when I graph that, it looks a little more egg-shaped than it actually is. If you do zoom square, zoom 5, it makes all of your x distances the same as your y distances. So I'm going to make sure that I have a couple points really nice on my graph. First is this point that in rectangular coordinates would be at 0 or 1, 0, which actually is our first point to graph there. And here I'm going to drag this right there so we can see it. The other point that I can see really nicely, 1, 2, 3, 4 up. So at pi over 2, my R value is 4. And same thing at 3 pi over 2. Oh, and on my key, I scaled this at 2 since my maximum R value here is 4 plus 3, which is 7. The way I have this goes out 5, so 6 would be here and 7 would be here. So that would be another point. Something else you can do, just to make sure that your shape is nice, is you can trace around. And see if you can get some other points there that would be good ones. There is 7, 3.14, just to check that maximum R value. 7 is your R, pi is your theta. So that's a nice one to see. So you guys know I am not an artist. I'm going to try to do as nice of a job as I can here. This is a limacon. It does not have an inner loop, since the first number is bigger than the second. It would be a cardioid if our two numbers were the same. So it was like 4 minus 4 cosine of theta, that would be a cardioid. And then this is symmetric over the x-axis. All right, let's do a rose. It's that curve. That wasn't super embarrassing, like drawing-wise for me. All right, 4 minus 3, or I'm sorry, 4 sine of 3 theta. So we know that this is a rose curve. Our maximum R value we should expect to be 4. Again, you don't have to have that memorized. We can double check it with our graph. Symmetry, since it's sine, we're going to be symmetric about y, but we'll double check that as well. And number of petals, if the number in front of theta is odd, that number is how many petals we should have. If that number was even, we'd have 2 times that many petals. Okay, let's check all that business with our graph. Back to y equals 4 sine of 3 theta. Three petals. Now the thing that I am going to be picky about when I'm grading is that your petals are on the right angle value. So I'm going to trace. .5235. Okay, I'm going to kind of drag that over here so we have a nice picture to look at while we're drawing. The other thing I'm going to check is what 0.3 or 0.5235 is. So to me that looks like it's pi over 6. And to double check that that's the decimal approximation, I'm going to put that pi over 6. Pi over 6 is that same decimal approximation, so I know that that's that angle. That means this angle over here, the angle in the second quadrant, is 5 pi over 6. And straight down, of course, is 3 pi over 2. That's going to let me make that nice graph. Okay, so pi over 6, and again, my max R value is 4, so I'm going to go 4 units out. 5 pi over 6, 4 units out. 3 pi over 2, 4 units out. And then do as nice of a job as you can. Yours on paper hopefully will look a little better than mine do on the smartboard. All right. For 9 through 16, graph those equations on your calculator and take a look at what they are. Go ahead and match those up. All right, that's polar graphing. The next video will be polar forms of a complex number.